find the unit tangent vector to the space curve r of t equals 2t, t e to the t, tan 2t at t equals 0. So if we have a space curve given by the vector valued function x of t, y of t, z of t, then the vector r prime of t, which is found by taking the derivative of each of the components, so component-wise differentiation, this vector will serve as a tangent vector to the curve. And just to demonstrate that briefly before we look at this particular example, if we have a line which would be given in the form r of t equals, and then we should have linear functions, and a line with direction vector ABC, and through the point x0, y0, z0 has the form x0 plus at, y0 plus bt, and z0 plus ct, then the derivative, r prime of t, should be the direction vector of the line. If in general r prime of t gives the direction vector of the curve, then that should work in the case of a line where you would get the direction vector of the line. So r prime of t, if we take the derivative here, sure enough, we get a, b, and c. Just to help us believe that this derivative vector will give us a direction vector for the curve. Okay, now let's find it. So in our particular case here, we have to take a couple of derivatives, 3 of them actually. R prime of t, the derivative of 2t is simply 2. The derivative of t e to the t, we have to use the product rule. T e to the t prime is t times the derivative of e to the t, which is e to the t, plus e to the t times the derivative of t, which is 1. So it's just this, which we could write as t plus 1 times e to the t. So 2, and then t plus 1, e to the t, and then the derivative of tangent 2t using the chain rule will be secant squared of 2t times 2. So this will give us the tangent vector at any time, any value of t. We're interested in time 0, so r prime of 0 is 2, 1, because 1 times e to the 0 is 1, and the secant of 0 is 1 because the cosine of 0 is 1 and the secant is the reciprocal, so it's 2, 1, 2. So that vector is tangent to this curve, and we would like to turn this into a unit vector, so we could call that vector, I don't know, u of t. And to make a vector into a unit vector, we just take the vector and divide it by its magnitude. So that would be, the magnitude is the square root of the sum of the squares, 4, 1, 4. So that's 9. So 1/3 of the original vector is a unit vector. So that's the vector 2/3, 1/3, 2/3. And a little bit more, we can make the equation of the tangent line to the curve. If we know a point on the curve, so when t equals 0, that gives us the point on the curve, or the position vector of the curve is 0, 0, tangent of 0 is also 0, so it's the origin. The curve is at the origin. So the tangent line, we talked about lines at the beginning. You need a point, and that's the origin, so I'll just skip that. And then the tangent vector, we can either use the unit tangent vector or maybe this one since we don't have any fractions. So the tangent line is the line given by, what should we call it? We'll just call it xyz. We'll just write it in the old vector form, equals t times 2, 1, 2. That's the tangent line in vector form.